Alright students, today we're going to talk about triangles and how their interior and exterior relationships help us find missing angle measures. So first we need to review all of the different triangles. We know a right triangle has one right 90-degree angle. Scalene triangles are triangles that have no congruent sides and no congruent angles. So all three sides would be different measures, which would make all three interior angles a different size. Isosceles triangles have two congruent sides and two congruent angles. You can see the markings, the two parallel lines on AB and AC indicate that those are equal, and the two angle measures match each other for angle B and angle C. Equilateral triangles say that all sides are congruent and all angles are congruent, so you can see the markings that indicate congruency. Okay, let's start by talking about interior angles of triangles. First, we need to know that the sum of three angles in any triangle, any of the types of triangles that we just reviewed, equal 180 degrees. So you can see that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. So let's use that understanding that all three angles inside a triangle equal 180 to calculate the value of x and solve for the missing angle measures. So if we know that all three angles together sum equals 180, then we can write the equation x plus 2x plus 20 plus x equals 180. Okay? We now need to combine like terms. So we can see that we have x, 2x, and x. All three of those are like terms, giving us a total of 4x plus 20 equals 180 degrees. We're then going to use inverse operations to isolate our x. We're going to start by undoing the addition with subtraction. 4x is equal to 160 because our 20s are a zero pair. We're going to inverse the multiplication by using division and divide by 4 on both sides. 160 divided by 4 would be 40, so x equals 40. Now that we know the value of x, we can determine the value of each angle. So this angle right here, because the expression is x, equals 40 degrees. This value right here would be 2 times x, so 2 times 40 would make this angle worth 80 degrees. And lastly, we have 20 plus x, so 20 plus 40 would make this angle worth 60 degrees. Okay, let's try example number 2 with a little bit harder expressions. So again, we know that all three angles inside a triangle equal 180. So we're going to create an equation, and we're going to set all three of these expressions up added together. So 8x minus 1 plus 3x plus 4 plus 3x plus 9 equals 180 degrees. Notice I did not put the parentheses around each expression. I'm adding all three expressions together, so I don't need the parentheses anymore to group my expression. Okay, I'm now going to go through and find common like terms. 8x, 3x, and 3x are all terms with x, so I can combine their values. 3 and 3 is 6, 6 and 8 is 14x. Okay? I also have terms that are constants, -1, +4, +9. 9 plus 4 would be 13, and 13 minus 1 would be 12. So our new equation is 14x plus 12 equals 180. I'm now going to isolate my x by inversing the operations. I'm starting with the addition, so I'm going to subtract 12 on both sides. My 12s cancel. 14x equals 180 minus 12, which would be 168. I would then divide by 14 on both sides, and x would equal 12. I could then use that value to find these degree measures. So I'm going to 8 times 12 minus 1. 8 times 12 would be 96, minus 1 would be 95 degrees. Then I've got 3 times 12 plus 4. 3 times 12 is 36, plus 4 is 40 degrees. And lastly, 3 times 12 plus 9. 3 times 12 is 36. 36 plus 9 would be 45 degrees. We can always double check our math by making sure all 3 degrees equal 180. So if we add 45 plus 40, we get 85, and 85 plus 95 we know equals 180. So we did check that all 3 together equal 180. All right, let's talk about exterior triangles now. Okay, so exterior angles are triangle. First of all, we need to understand that when we're talking about exterior angles, we're simply saying that if we extend one of the legs of a triangle beyond the triangle itself, so outside of the triangle, okay, the exterior angle that is created right here, this 135 degrees, is the supplement of the interior angle, 45 degrees. Together they equal 180. So this relationship right here is a supplementary relationship. The exterior angle theorem says that since this is a supplementary relationship, and since you know that all 3 angles inside a triangle also equal 180 degrees, then the angle measure of the exterior angle is going to equal the 2 remote interior angles added together. So the 2 interior angles that are away from the supplement. So C is the supplement. The A and the B that are separated from that supplement, those 2 added together will equal the value of that exterior angle. Okay, so that's what we know from the exterior angle theorem. So let's practice that in a couple examples. This is example 3. We see that we know from what we just learned that the interior angle here plus the exterior angle here together create a straight line. So the relationship is 180 degrees. So we can write an equation that says 5x plus 120 equals 180. And we can solve for x by subtracting 120 on both sides. 180 minus 120 would give us 60. So 5x equals 60. And then we divide by 5 on both sides. And 60 divided by 5 is 12. So we know the value of x is 12. Okay, in example number 4, it gets a little more complicated. This is where we're reviewing that exterior angle theorem that says that the exterior angle here is equal to the 2 interior angles added together, the 2 remote interior angles, so angle A and angle B. So we know that angle A plus angle B has to equal, we're going to call this angle out here, this interior one C, we're going to call this one D, okay? So it has to equal angle D. Now angle D was given to us, 116 degrees, so we can put 116 underneath that. Angle A is an expression, 3x minus 13. And angle B is an expression, 2x plus 4. Okay, so angle A, I have all kinds of little mistakes happening with my pen. I'm sorry guys, that's kind of confusing. So this was a minus sign and a 13, and this is an x right here. Okay, so 3x minus 13 plus 2x plus 4 equals 116. So again, we're going to combine like terms. So our 3x and our 2x combine to give us 5x. And our negative 13 and our positive 4 will combine together to give us, let's see, negative 9 equals 116. So now I'm going to add 9 on both sides. The 9's cancel. 5x equals 116 plus 9, which would be 125. I then want to divide by 5 on both sides. And 5 goes into 125. 25 times. So x equals 25. I can then use that to solve for B and A individually. So 3 times 25 minus 13. 3 times 25 is 75. 75 minus 13 would be 62 degrees for this corner right here. And then if we're going to solve for this one, we're going to do 2 times 25 plus 4. 2 times 25 is 50. 50 plus 4 would be 54 degrees. So this one right here would be 54. We can check by making sure that 62 plus 54 equals 116, and it does. And so we know that we have solved for x correctly because the theorem works. All right, you have 2 examples you're going to do. One is an interior triangle problem where you're solving for x, and the other is an exterior angle relationship where, again, you're solving for x. I do want you to plug x back in and tell me what the angle measure is here, the angle measure is here, and the angle measure is here and here. Okay, so tell me what the value of x is, as well as plugging it back in to solve for that angle measurement. Okay, bring these back tomorrow with any questions you had after watching this video. Thank you, guys.